In today's lesson, we're going to be looking at solving right triangles and introducing a couple new words. We're going to talk about angles of elevation and angles of depression. And so in the first part, what does solving a right triangle means? When I ask you to solve a triangle, all I'm asking you to do is to find all of the unknown angles and all of the unknown sides. So for example, in this question, I am missing one side and two angles, and so I need to find those. And there's lots of different ways we can do that. For example, one thing we could do, we always have this tool. If I wanted to find this side, I could use my Pythagorean theorem. A squared plus b squared equals c squared. That's one option, okay? Or instead, maybe we want to find an angle first, okay? We could find this angle D, or we could find angle F first. If I want to find angle D first, I would use the appropriate ratio given the two sides, my opposite and adjacent. So I would find angle D using my opposite and adjacent ratio, and whenever I'm finding the angle, I take the tan inverse of the ratio, correct? And so I type that into my calculator, and I get 42 divided by 31 is the tan inverse of that ratio is approximately, I'm just going to round to the nearest degree, 54 degrees. So I now know that this angle is 54 degrees. I could do all of the work again to find angle F using opposite and adjacent. I could do that, but don't forget we know that the three angles in a triangle add up to 180, and one of the angles is already 90. Therefore, I can just say, well, angle F is going to be 90 degrees, subtract angle D. So we subtract those two angles and get 36 degrees. That's a lot easier than going through all that work again. So pick the most efficient way of finding angles and sides. So once I found one angle, I now know two of the three, so I can just subtract to find the third. Okay? And so now let's find DF, and again, I could use the Pythagorean theorem. I now could be using, now I'd have all the information, I could be using opposite over hypotenuse, or I could use adjacent over hypotenuse, right? Or I could be using the other angle and doing all of that. It's up to you. It doesn't matter, okay? So if I was to use the Pythagorean theorem, it would be x squared equals 42 squared plus 31 squared. I would take my 42 squared plus 31 squared, and I would get x squared equals 2,725. Therefore, x is the square root of 2,725. I type that on my calculator, and I get approximately 52.2. The nice thing about using the Pythagorean theorem here, rather than going over here and using the 54 degrees, is what if I got 54 degrees wrong? What if I made a mistake? Well, I'd be using a wrong number to find x, and therefore x would be wrong as well. Or, like I said here, I'm just going to round to the nearest whole number. I rounded off quite a bit to get to the 54 degrees. So therefore, I'm using a rounded off number to find x. So again, I'd probably lose a little bit of accuracy. I wouldn't be wrong. I just now know this number is more accurate because I used information that was given and not rounded off. And I knew that these numbers are true because they were given and I didn't have to calculate them. So it's always good to make good decisions, especially on a test, whereas if this number depended on knowing this number, you would be getting both of them wrong if you did step one incorrect. All right, so now we're going to move on to our two definitions, angles of elevation and angles of depression. An angle of elevation is the angle created in a upwards direction from your horizontal. It's always taken from a horizontal, right? So if it's from the ground here, it's the angle up. This would be my angle of elevation, to elevate, to go up. Vice versa, our angle of depression means to go down. And again, it's taken from that horizontal line, okay? You can see this is a vertical line. It's not taken from that line. That is not an angle of depression, okay? So angles of depression go down from the horizontal. Angles of elevation go up from the horizontal. If I draw a line between the two, you can see that letter Z. okay? And again, horizontal lines are parallel to each other, so I have a letter Z with parallel lines there, right? So another thing is we can see in math, we call these alternate interior angles. Or in other words, if this was a 30 degrees, this would also have to be 30 degrees, because think about this. If this was 30 degrees and this is a 90-degree angle, that would have to be 60 degrees, right? And those two angles in a right triangle would have to add up to 90. So if that's 60, that has to be 30, right? So the angle of depression can be transferred down to the angle of elevation. They are equal to each other when you connect that line between the two, all right? So if someone is looking straight ahead, they're looking straight ahead, their angle of elevation, if they're looking at something up high, is taken from that horizontal line to their line of sight, to what they're looking at. Or if they're looking down at something, they're standing on a hill and looking down, the angle of depression is taken down to their line of sight from that horizontal. It's always taken from their eyes. Okay? So for example, if from a boat looking up to a plane, the angle of elevation is 20 degrees, I can also say the plane looking down at the boat has an angle of depression of 20 degrees. If I wanted to fill in this angle over here in this triangle, it would have to be 70 degrees, right? Those two, right? This one is not an angle of depression, but it is complementary. It's the angle that adds up to 90 to create a sum of 90. Okay? All right, so let's practice just a couple word problems so we understand how to put these angles of elevation and angles of depression into our problem. So a reminder, when you are trying to draw out a word problem, don't draw a right triangle and try to stuff the problem into the right triangle. Draw out the scenario and then look for right triangles. Okay? So a surveyor needs to determine the height of a large grain silo. Okay? So I'm going to draw a grain silo, but I always start off by drawing my ground as my point of reference, and then I have my grain silo. Whatever it happens to look like, we'll make it a cylinder shape. Okay? And he wants to determine the height of this. That's what I want to find out. He positions his transit, so it's like a little machine that lasers and measures distances and angles. So he has this little like tripod transit sitting on the ground, right? It's not right on the ground. It has like legs, and so it's going to be sitting at 1.7 meters above the ground. That's the height of that transit right there, okay? And he records an angle of elevation of 52 degrees to the top of the silo. So this is where it's going to be tricky. Where do I put that 52 degrees? Well, he's taking that measurement from the transit right here to the very top of the silo, right? That's what he's looking at, okay? That's his line of sight, or the transit's line of sight. But don't forget, that line of sight is not taken from the ground, it's taken from this horizontal. So I have to put both of those into my diagram. So I have to create my horizontal reference and my line of sight. That is the angle of 52 degrees. Okay, so I'm drawing all this in, and now I'm going to look for right triangle. And then I'm going to fill in what I know. My right triangle exists right there. That's my right triangle, with my 90-degree angle being over there. So I know that this angle in my right triangle is 52 degrees. All right, what else do I know? I know that his transit is 65 meters away from the silo. So that distance in the triangle is 65 meters. Right? So now that I see my right triangle, I can put all the information on. I want to know the entire height of the silo, but the triangle only takes me from here to here. So I'm going to call this, I don't know, maybe H right there, from there to there. I do know that this transit's 1.7 meters high, so I can fill in the rest down there. So I just filled in as much as I could. So now I know if I find H and I add it to 1.7, I get the entire height of the silo. So using my right triangle, I can now find H using opposite and adjacent. Oh, that's the tangent of 52 equals opposite over adjacent. Multiply both sides by 65. Now multiply that out, 65, tan 52. gives me about 83.2. Or 83, we'll round off. Or we'll leave it at 83.2 because this is 1.7. All right, so now I know the height right there is 83.2. So now I have to take my 83.2, add it to the 1.7, and now I can get my 84.9 meter height of the silo. Okay, so drawing your diagram is essential to being able to answer the question correctly and labeling it. All right, let's try one more diagram. From a helicopter, the angle of depression to the nearest city east is 8 degrees. The angle of depression to the nearest city west is 12 degrees. Let's determine the height between the two cities. No, not the height. Determine the distance between the two cities if we know the height of the helicopter. All right? So again, we're going to draw our ground as our reference, right? We know our directions. We know our north, east, south, west. So the helicopter's in the middle. If one city's east and the other's west, then the helicopter's between the two cities, right? So we have this helicopter up in the air, right? With the, I don't know, terrible drawing, but we get the idea. So we have the helicopter. We have, here's city to the east. Here's another city to the west, okay? And I know the height of the helicopter. Reminder, I like to put like heights, vertical heights as dashed lines because they're not actual things on my diagram. They're concepts, right? They're heights without being a physical part of the diagram. So that's 750 meters high. So now we know the angle of depression to the city east. So this is the city east over here, right? So the angle of depression to that city is 8 degrees. So here's the deal. Most people like to put the 8 degrees there, and that's where the number one mistake is made. That is not an angle of depression, right? The angle of depression is always, always taken from a horizontal. So I have to create that horizontal concept, 8 degrees. So remember, do you see the Z? Z. Whenever I can create a Z like that, I can also transfer that 8 degrees down there, right? So if that angle of depression is 8 degrees, I can also say the angle of elevation is 8 degrees. It's a very handy tip. Or I could finish off this and say, well, this is 92 degrees because, sorry, not 92, 82 degrees, because those two angles add up to 90, right? So either way, I prefer just to transfer it down. I think it's easier that way, okay? So now let's take a look at the angle of depression west is 12 degrees. So here's my city west, and it's going to be 12 degrees, right? Again, 12 degrees is always taken down from a horizontal. My 12 degrees is there. And again, looking at my Z, I can transfer my 12 degrees down here, okay? So I now have two triangles. I have this left triangle and I have this right triangle over here, the one on the left and the one on the right. And now I can use these two triangles to find the distance between the two cities, right? So I have to treat them separately because the whole triangle altogether is not a right triangle, so I can't use SOHCAHTOA. But I could use it to find the distance between there and there, and I can use SOHCAHTOA to find the distance between there and there, and the total distance is x plus y. So if I now want to find distance x using this triangle here, I'm going to use opposite over adjacent. So I'm going to say the tan of 12 degrees equals opposite over adjacent, or x is 750 over tan 12, and I type that in as 750 divided by tan 12, and I get 3,528.5, is that kilometers? Oh, meters, we're in meters. This unit is in meters, so we stick in meters, right? So I can change that if I wanted to 3.5 kilometers. not very far, so these cities are pretty close. But anyway, going over here, I can do the same thing. The tan of 8 is equal to 750 over y. So y equals 750 over tan 8. And I type that into my calculator. And I get 5,336.5. So now when I add these two numbers together, I get total distance being 8,865 meters, or just under 9 kilometers apart. All right, so the key is drawing the diagram and placing your angle of depression properly and transferring it down to the angle of elevation to get inside your triangle. Okay, number one mistake is angles of depression get put against the vertical versus the horizontal, right? So people who try to draw a triangle and then try to put in angles of depression, etc., that's where you make mistakes. Draw your diagram, place your angles, then look for triangles, right triangles, and move angles around as necessary.